Hey everyone, my name is Denise Gosnell, and this is Declarative Traversals. Now, declarative traversals require you to think differently. Instead of trying to instruct a traverser on how to compute a result, we declare how the result should look, and we let the traverser just find a solution. Gremlin declarative traversals are graph pattern matching traversals. They specify a graph pattern that should be matched against a graph. So let's visualize this. A gremlin outside of the graph is thinking of the triangular pattern of those three vertices that you see in the diagram. That is a pattern we will define with the gremlin language, and the actual traversers in the graph will be looking to find that pattern. The gremlin outside of the graph is thinking of the triangular pattern of those three vertices you see in the diagram. That is a pattern we will define with the gremlin language, and the actual traversers in the graph will be looking to find that pattern. As with any programming language, a declarative approach describes an outcome that we want, a thing that we want to happen. It doesn't give us the steps or how to get there. In other words, declarative traversals focus on what to compute, rather than how to compute it. For declarative traversals, we only need to introduce one new step. It is the match step, and it has three different forms that we can use it in. In all three cases, we provide the patterns we would like to match. In the first case, we provide named variables at the beginning and at the end of the traversal. In the second case, we only provide a named variable at the beginning of the traversal. And in the last case, there are no declared variables. Notice that declarative traversals use the as step modulator to declare variables that have to be bound to some values in the solution. We used the as step previously with projecting traversals to define step labels, but in declarative traversals, the terminology is different. We say in declarative traversals that the as step creates variables instead of step labels. Let's take a look at some examples. A reminder as always of our killer video movie schema. Users know other users, users rate movies, and movies belong to genres. We also have people who acted, directed, composed, or other types of participation in the movies. Let us start with the same example from the projecting traversals video, directors who appear in their own movies. We have solved this before, but we're going to solve this same query with a pattern matching traversal. We're going to provide two different patterns. Each pattern starts with a gremlin anonymous traversal. We're going to specify the pattern after that. Also, notice that we are going to use the first of the three pattern forms, where we have a declared variable at the beginning and at the end of the declared pattern. In this traversal, we are going to provide two different patterns. Each pattern starts with a gremlin anonymous traversal, the double underscore. We are going to specify the pattern after that. Also, notice in this example that we are using the first of the three pattern forms, where we have a declared variable at the beginning and at the end of the declared pattern. How we are using those declared variables is one of the most important pieces in this example. Looking at each of the patterns, we are using the same variables m and p. When we use the same name for a declared variable, that will bind to the same value. So we are defining two patterns, but they will apply to the same movies and the same people. So in this traversal, the first pattern in the match statement is going to look for some movie with an outgoing actor edge to some person. This finds actors in some movie. The second pattern in our match step is going to look for an outgoing director edge to a person. But because we use m and p, and they're the same declared variables in both patterns, they're going to be constrained to be the same movies and the same people. In other words, we're constrained to directors who acted in their own movies. Once we've done this match step, we're going to select the people, remove their duplicates, and randomly sample three. And for the movie buffs out there, we found hopefully three expected results: Clint Eastwood, Charles Chaplin, and Quentin Tarantino. Before we move on, there's two things to note about the match step before going to the next example. First, the database engine can evaluate traversal patterns in any order to compute the same result. So if your application requires deterministic results, you'll need to apply an order to the result stream. Secondly, and you may have already noticed, at the end of this traversal, the select and the by steps are used just like in projecting traversals to return the desired information. In this next example, let's look for directors who have appeared in their own Western movies. We will follow the same process as before, but this time we will need to bring in the genre vertices. We're going to follow the same style of match again by using declarative variables at the beginning and at the end of each pattern. And we're also, again, going to use the same variable names as we did in the previous example. Now we're going to follow the same patterns as before that we saw in the previous example, but in this one, we need to add a third pattern. We're going to start by finding the actors and finding the directors as we did previously, but next, we need to add a pattern to make sure that the movies we're identifying belong to the Western genre. And that's what you see here with the third pattern in this match statement. We're identifying that the movies belong to a specific genre with the name of Western. We're going to go ahead and select P by their names and dedupe them and take a sample of 3. And we find Clint Eastwood, John Wayne, and Quentin Tarantino. Adding on to this example, let's add just a little bit more complexity. But this time, we're going to introduce a new pattern with the not step. We're going to look for directors who acted in their own movies again, but this time they're going to be comedies. And we're going to add one more constraint. We want that those actors and directors have never participated in any movie that has an average rating of less than 8. As you can see in this traversal, we start off the same. We have M, which has an outgoing actor edge to P. M also has an outgoing director edge to P. So following these two patterns, these are the directors who have acted in their own films, as we've seen before. Next, M has a belongs to edge whose name is comedy. So this means that the movie belongs to the comedy genre. On the next line, we begin with the not step. So we are going to negate what we are about to traverse. But first, we have to compute the average rating for the movie. This time, we want to consider any movie the actor or director has participated in. So we start from P, and we go to any movie via all of the different in edges. Next, we want to compute the movie's average rating. This introduces the need for the local step. We have to use local here so that we calculate the average for that movie instead of the average ratings for all movies. From here, we have 4 remaining steps. First, we walk out the ratings edge. Next, we access the ratings values by calling values rating. Third, we use the mean step to calculate the average. And lastly, we only want that traverser to pass if the average rating for the movie is less than 8. Now remember, that is all inside of not, so we're going to negate this part of the pattern matching step. So with this final pattern, we're limiting the results to only those directors who appeared in their own comedy movies and have never participated in any movie that has an average rating of less than 8. So let's take a look at these newly introduced gremlin steps. The not step passes an incoming traverser onto the next step only if the internal traversal yields no results. The and step passes an incoming traverser onto the next step if every internal traversal yields a result. The or step passes an incoming traverser onto the next step if at least one internal traversal yields a result. These steps, while frequently used with declarative traversals, are not limited to just this match step. They can be used with imperative traversals as well. Let's put these to practice and consider another example in a little bit of a different style. This time, we're going to find actors who appeared in 10 or more movies, and they acted in The Matrix or Die Hard, and the actor's name is not Alan Rickman. Using the match step, we will break that down into separate patterns. This example demonstrates the use of and, or, and the not steps. So to do this, let's break it down into each segment. In this first pattern, we're going to look for all actors who acted in 10 or more movies. The next pattern, we want to find those actors from The Matrix or Die Hard, but not Alan Rickman. To do this, we need to build up a series of or statements inside of the or step. The first statement we want to evaluate is if an actor has been in The Matrix. To do that, we want to traverse from people, going through the actor edge, and only consider movies named The Matrix. We want that statement to be true, or we want to find people from the movie Die Hard, which is what we're introducing with this next pattern. In this next pattern, we want to consider those actors from the movie Die Hard, and if they did not have the name Alan Rickman. For the second pattern, we need to build up a series of or statements. For the first statement, we want to only consider actors who have been in the movie The Matrix. And that's the first section of this traversal that you see. On the next line, you see that we only want to now consider the actors who have been in the movie Die Hard. But we also want to limit those to the actors who are not Alan Rickman, which is what you see on the following line. We're going to select the actors by their name, and we see here that we have Bruce Willis and Keanu Reeves. In our last example, we're going to mix declarative and imperative traversals. We want to find directors who directed 5 or more adventure movies, and then we want to find adventure movies rated 8 or higher. In the first match step, we're looking for the directors that directed 5 or more adventure movies. Then, after we select those directors, we're going to add in an imperative traversal to get us back to the movie vertices. From those movies, we want to do another set of patterns to find the adventure movies that are rated 8 or better. The first pattern, we're going to find those movies that belong to the adventure genre. The second pattern, we're going to find the movies whose average rating is greater than 8. At the end, we're going to select the movies and select their directors by title and by name. From the movie vertices, we want to do one last match step with 3 different patterns. First, we want to find the movies that belong to the adventure genre. Next, we want to compute the average rating for all of those movies. The third pattern guarantees that that average rating is greater than 8. We'll select the movies by their title and the directors by their name, and we'll see the results here. We have 3 versions of Lord of the Rings: The Return of the King, directed by Peter Jackson, Fellowship of the Ring, and then The Two Towers. Now, I know that was a lot, so give this next exercise a try and put declarative traversals into practice.